Okay, so here we have a sort of a goals for the hour. So number one, reinforce core ML concepts. That will go for about 20 minutes. Quickly review the most fundamental ML terms and trade-offs. Then number two, touch on system design. That is another 20 minutes. Understanding the major components and considerations for building an ML system. Then we have review MLOps and deployment for about 10 minutes. Briefly recall the steps for getting models into production. Then we have prepare for behavioral or situational questions. So that is like about another 10 minutes. Quick examples for common questions. So for instance, for the first 20 minutes, core concepts. So bias variance trade-off, of course, high bias underfitting versus high variance recall. The mitigation is regularization techniques like L1 regularizer, L2 regularizer, then cross validation, more data, simpler complex models. Then we have evaluation metrics. So we have classification, for instance, precision, recall, F1 score. Hey, area under curve, ROC curve. Then we have confusion matrix, true positives, false positives, etc. And when to use each of these metrics. Uh, then we have regression, MSE, MAE, root mean square error, mean average error, etc. Common algorithms we have here, briefly recall their purpose. We have supervised, unsupervised. So for supervised, for instance, we have linear regression, logistic regression, decision trees, random forest, gradient boosting, XG boost, large GBM. There are lots of stuff, have to catch up within the time frame, so no time to go deep in any of them, but common core concepts need to touch on the core concepts. So support vector machines and neural networks basics. Then we have unsupervised, for instance, k-means and principal component analysis. Data processing, we have missing values, how to deal with missing values, imputation, mean, median, mode, removal. Then outliers, for instance, removal, transformation, capping. Then we have categorical data, how to deal with categorical data, how to encode them, one-hot encoding, level encoding. Then we have scaling, how to scale the data to prepare them to feed into whatever network or classifier, whatever we are using. So we have this normalization and standardization options. Then we have the deal with overfitting, underfitting, which also goes again once again with bias variance trade-off, model size as well. Then we have about 20-40 minutes for system design, high level. So think about the pipeline. So first start with the problem definition. Start with clarifying questions. What's the business problem? What is the success metrics? Offline, are you going offline or are you going online? Then I have data ingestion and storage. Where does the data come from? Where do we store it? Data lake, data warehouse. What are the options we are choosing and why? Data pre-processing, feature engineering. How do we prepare the data for modeling? Then we have the model training. How is the model going to be trained? Do we train it online or do we train it in batch or as a mixture of both? What infrastructure is needed? Then how do we serve the model? How do we do the inference? How do users get the predictions? Batch, real-time API, latency considerations. Then of course we will need monitoring. How do we monitor the model performance in production? Data drift, concept drift, prediction drift, latency, errors. Then we have the retraining strategy. When and how do we retrain the model? Scheduled, on demand, or triggered by drift. So the key considerations here, like scalability, how will the system handle more data, more users, latency, real-time or batch prediction. For real-time, how do you deal with the latency, how fast can you serve, reliability, how do you handle failures, and then we have of course cost, cloud resources, and human engagement, human level data, or do you introduce synthetic data, how much of our data are synthetic, how much if we use more human level we have a little bit more cost. There are these trade-offs, of course, performance or complexity, cost versus accuracy. Then for another 10 minutes we have ML deployment, ML ops and deployment, quick scan. So core ML ops concepts, continuous integration, continuous development, CI/CD, automatic testing, building and deployment of ML pipelines and models. Can talk about a little bit about the available tools. Then we have model registry, versioning and managing the models. Feature store, centralizing and serving features for training and inference. Then deployment methods, how do you deploy the models for inference. So REST API for real-time inference, batch inference for large data sets periodically. Then we have edge or on-device for constrained environments. Then a little bit about the key tools: MLflow, Kubeflow, Airflow, Docker, Kubernetes, cloud-specific services like SageMaker, Vertex AI, Azure ML. There are plenty of options out there. Prometheus for monitoring. Then we have this behavioral and senior level questions. It is more of like a mental preparation. So think of 2-3 strong project examples. One where you solved a challenging ML problem, one where you demonstrated leadership or mentorship, one where you dealt with a conflict or a failure and learned from it. Prepare an answer for, tell me about a challenging ML project. How do you handle disagreements with stakeholders, members, situation, task, action, response. We had it in software engineering as well, STAR method. Then discover time you failed or made a mistake, focus on learning and corrective actions. How do you stay updated with ML trends, conferences, papers, blogs, open source. Why this role or this company connect to their specific products or challenges. So alright, now